Today we will be looking at the next type of variation, which is inverse variation. Now, inverse variation is nonlinear. Its equation is y is equal to k over x. Remember, where k is your constant, just like with direct, we're going to find it first. And I want to quickly talk about how I remember this one is because of inverse. Inverse is up and down, right? So if you are familiar with video games and you have inverted joysticks, when you move your joystick up, you really look down. When you move your joystick down, you really move up. Just like with trackpads on a computer, you can have an inverted swipe so that if you swipe up, you really move down, and if you swipe down, you really move up. All right. The graph is going to look something like this. So it's kind of going to look like an exponential function. Just backwards. Another key thing to remember is as x goes up, y goes down, or as x goes down, y goes up. All right, so x's and y's move in different directions. All right, so these are the only rules. Now we'll do a couple examples. Again, you can do, if you're unsure about equations, just go to Desmos. All right, so my Desmos ain't working this morning. So y is equal to 4 over x. Again, this is yes, because I have my constant, which is a k value, divided by an x. So you will always see division for inverse variation. D is not because there's no division. B is no because there's no division. E also no because there's no division. C also no because there's no division. F, I see division. Pi, even though it may look like a variable, that's my constant because we know its value is 3.14, blah, 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 blah. Again, a known value divided by x. So this is yes. All right. To actually find them, okay, again, we're going to find k, use that k value into the second equation. All right, so again, y, whatever varies is on the left. Inversely is going to tell you division. What does it vary with? X, if y is 7. So y is 7 when x is equal to -4. Again, find k first. Way you get rid of division is multiply. So 7 times -4 equals k over -4 times -4. What this does is being -28 is equal to k. So we're going to use this k value. So find y. K, which we now know is -28, when x is 5. All right, and again, get your variable by itself, which we just did. So y would be -28 over 5. Now this time over here on the right, we don't have x and y. However, we have a and b. Again, whatever varies goes on the left. So A varies, tells me A is on the left. What type of variation? It's inverse, that tells me it's division. Some constant. And what does it vary with? B this time. So there goes my formula. If A is 4, when B is 16. Again, I need to get rid of this fraction, so I'm going to multiply both sides by 16. So times 16 times 16, I get 64 is equal to K. Once I solve for K, I'm going to use this value to then find whatever variable is missing. Find B when A is equal to -2. So -2 is equal to 64 over B. Again, get rid of the fraction by multiplying both sides by what's on bottom. So multiply both sides by B. I get -2B is equal to 64. Divide both sides by -2. I get B is equal to -32. All right, so if you're finding your variable or solving your new value for the variable in the denominator, it's just a little bit more steps, but it's not terrible. All right, remember, just get rid of your denominator, then find a way to solve for your missing variable. Again, does the following graph accurately represent inverse variation? Support your reasoning, yes or no. Again, this is Y values and X values. If I think about these being numbers, so again, does it fit the formula Y is equal to K over X? Is it nonlinear? And does it fit either one of these? All right, so as X goes up, Y goes down, or as X goes down, Y goes up. So I don't have an equation, so I don't know about this yet. It is nonlinear, so that works. And as X is increased, so as I go from left to right on my graph for my X's, I'm increasing. As I increase, my Y values are going down. Okay. Now, another way I could think about it is my X's decrease. So as I go from 4 to 3 to 2 to 1, so as I'm getting smaller XY's, my Y values are increasing. All right. Now, it kind of has an arc to it. So all of these are going to be yes. If you're given a table or set of points and no equation, remember, you have the formula Y is equal to K over X. All right. Is it nonlinear? And again, does it fit I'm going to rewrite this table here because it's kind of a goofy table. What I mean by it's goofy is that it's written not in order. So 2 to 1 to 3, so X goes down and then X goes up. So I'm going to clean it up just a little bit. Pay attention to that in these problems. Okay, so as X is increasing, 1 to 2 to 3, Y values are -3, -6, -12, so Y is indeed going down. And as X goes down, so 3, 2, 1, decreasing, Y's are getting bigger. Now, going from 1 to 2 is a change of 1. Negative 3 to 6 is a change of 3. 2 to 3 is a change of 1. Negative 6 to negative 12 is a change of 6. Because my change is different, I know it's not linear. Now, for these, because I don't have a picture, so you could graph it if you wanted to, but I'm going to show you how you can pick a couple of points and test this. So again, if I know y is equal to k over x, I'm going to plug in some values here. So when y is equal to negative 6, x is equal to 2. I want to solve for k. So multiply both sides by 2. And I get negative 12 is equal to k. Now, this constant must be the absolute same for all of the points given. If it's not, then even though all of this stuff is true, it doesn't hold true to the form. Therefore, I know it is not inverse. So y is negative 3. K over 1. Get k by itself. So I'm going to multiply. I get negative 3 is equal to k. Now, compare my k's. Negative 12, negative 3 are different values. And the reason this does not work is because I can say negative 12 is equal to k, and then k is equal to negative 3. So if I write this out, negative 12 is equal to k, and then will I have k is equal to negative 3 if I get rid of this k, right? So if I shade it out, negative 12 is not equal to negative 3. So this is not inverse variation because my k's are different. So variation, your k must be the same from all of your sets of points. The speed you must go over a certain distance varies inversely with the time of the trip. Suppose you travel 54 miles per hour to complete your trip. If it takes you 4 hours, how fast must you travel to complete the trip in 3 hours? Okay, so the speed varies inversely with time. So speed varies inversely with time. And again, I have some constant. So 54 miles per hour is my speed, is equal to k over x, or k over time is 4 hours. Again, get k by itself. Multiply both sides by 4 is 216 is equal to k. How fast? So what's my speed needed? 216 over 3. And that is speed must be 72. So again, not terrible. Again, whatever varies goes on the left, and then your equation is going to, or the rest of it is going to go on the right. Constant up top, whatever it varies with is going to be your bottom. Don't write just X's and Y's, A's and B's. All right, that's again why I like word problems, is because you can put words here. All right, words are a lot easier to find than just, letters or put meaning to.